Welcome to the Embedded System Design using ARM Cortex M4 series. I warmly welcome you to the session. Thanks for your time and thanks for coming today. And today is day 21. And today's topic is LCD, okay, liquid crystal display. So we'll be learning what is LCD, what are the different types of LCD available in the market, and the pin details of the LCD, and how to interface LCD with STM32F411 series, and how to write a program to display hello in 16x2 LCD. Okay, how to write the function for command mode and how to write the function for data mode. So these are the things which we'll be covering up today. At the end of the session, I'm sure that you will be writing your own program on LCD interface with STM32F411 series. Okay. So LCD is liquid crystal display. Usually it is used for display devices for embedded system design, so that you could you could give some message for the user. Okay, so usually, like, there are different types of LCD. Like, you have 16x2 LCD, which is the basic version, and you also have 16x4 LCD, and you have SPI based LCD, parallel LCD, SPI based LCD, like this serial peripheral interface, SPI based LCD, and I2C based LCD, inter-integrated communication. Based on the protocol, there are different types of LCD, and based on the materials also, like, there are different types of LCD. Okay, so in today's session we'll be using 16x2 LCD. Like, in 16x2 LCD, like, you have, these are the pin details. Like, you have the ground pin and 5 volt, so you need to connect a ground and 5 volt to this VCC. Okay, and contrast control, which has to be connected via the pot meter. Okay, 10K pot meter. I'll show you the schematic diagram on the next slide. And you have register select, RS, and read write. Okay, so usually like, we'll be using for write. Okay, it's very rare to read, and you have, but it has an option to read. Okay, so read the data from the LCD. So whether it is read operation or write operation, and this is for enable, and this is for data pins. Okay, so you can send an 8-bit data. It can also, LCD can also be used on 4-bit mode. Okay, so but today class we'll be using the 8-bit mode, and you have LED plus and LED minus for backlight. Okay, so if you give a VCC, 5 volt VCC and ground, like, you get the backlight for the LCD. Okay, and these are the codes. You can download the codes from the data sheet of the LCD. Usually, like, whenever you purchase LCD, some data sheets, some LCD might differ. Like, you have to refer with the part number and the data sheet. So the generic used codes are, like, for clear display screen, like, the hex value you have to pass 01. For these are the commands which you have to give to the LCD. Okay, for return home 02, for cursor to return home 02, for decrement cursor it is 04, and for increment cursor it is 06. Shift display right, okay, and left, and display off, cursor off, display off, cursor on, display on, cursor off. Okay, so these are the various codes. And to choose whether it is 2 lines and 5x7 matrix, it's 38. Okay, but sometimes based on the LCD, it may differ. You have to cross verify. In some cases, you can find out the data sheet is 28. Okay, the LCD what I'm going to use is 38. Okay, so you have to cross check once with the LCD what you have. Okay, for some LCD it is 28. For some LCD it is 38. The rest of the codes are same. And this is a schematic diagram to interface LCD with the microcontroller STM32F411. So we'll be using 2 ports today, GPIO port B and GPIO port C. And this is the connection for the contrast. You can use a 5K part meter or 10K part meter. And this is the microcontroller data pins. Okay, in 4-bit mode, D4 to D7 is used. Okay, and these lines D0 or D3 was left unconnected if you use the LCD on 4-bit mode. Okay, if you use the LCD on 8-bit mode, then you have to connect all these 8 lines. Okay, and 5 volt, you can use current limiting resistor 330 ohm connected to the anode. Okay, so for us today, like, we are going to use on 8-bit mode. So we'll be using from D0 to D7. So from the nuclear board, we have used today port C for D0 to D7. Okay, from PC0 to PC7, you have to connect to D0 to D7, and PB5 is RS. Okay, and PB6 is read or write, and PB7 is enabled. Okay, so port B for the control signals, and for data signals like for command and data, you can use PC0 to PC7. Okay, so PC0 is here, PC0, PC1, PC2, PC3, and PC4 is here. Okay, and PC4 like PC 5, 6, and 7 is here. Okay, and PB5 and PB6 and PB7, PB6. Okay, PB6 is here, PB5 is here. Okay, and PB7 it must be here. Okay, PB7 is here. Okay, so we have connected. You have to connect this. I just show the connection details. Like this is how I have connected the hardware. Like I have a breadboard and I have a nuclear board, which is connected at the which I have used the 5K 5K part meter here. Okay, 5K part meter is connected here. Okay, so if I adjust, then like you can vary the contrast. Okay, you can see like, okay, okay. So today, like we are going to the registers, what we are going to use is you need to enable the clock, because we are going to use GPIO B and C. So it is connected to AHB1. So you have to enable the clock access for AHB1 here. So you have to set GPIO C here and GPIO B. You have to set 1 and 0. Okay, 1 and both 1 and 2 as 1. Okay, so in the AHB1 here. Once it's done, like the mode register, GPIO mode register, we are going to use you need to use both the B and C. Okay, so for C you need to set from 0 to 7 as output mode, 0 1. Okay, so you have to set 0 1 0 1 here, so 0 1 0 1 0 1 0 1 0 1 0 1, so it's 5. Okay, 4 5 you have to set. And for you have to enable, you have to configure the output mode for GPIO B also, because we are using GPIO 567. We are using 567 as output, and C0 to C7 as also output. Okay, so you have to set both. So today I'm going to use the header file from the ST Microelectronics. So I'll show you how to do that, how to download the header file, and how to include the header file. Okay, and you can access the registers instead of in usual, like we'll be using the SFR's memory address, and we'll be using a pointer variable for declaring that. But today we are going to use the inbuilt header file. Okay, so we are going to download the header file from the ST Microelectronics website, and then we are going to use. Okay, so ODR, output data register, to send the data to the LCD. Okay, and bit set register, BSRR, you can use BSRR for setting only the particular bit. Okay, so you can use this for the control signals, for read write or enable, or for register select. Okay, so let's so first I will explain the code on the presentation, and then we can go for the STM32, and we can open a project, and I will write the code from scratch. Okay, so coming to the macro definition, so RS is 20, RW is 40. So these value, so if you check out this binary value, this is the hex value. If you check out the binary value, this is the code. We have given 20 because we use PB5. Okay, so we use PB5 to choose to enable PB5. So you have to use this hex code. Okay, if to PB6 it's 40. Okay, so PB7 is 80. Okay, so we have to define the macros for register select, because register select is connected to PB5. Okay, and PB6 is connected to read or write. So we have to use this code, and enable is PB7. Okay, and we need to declare the function declaration, the prototype declaration. Okay, and GPIO underscore init function for initializing the GPIO, and LCD data and LCD command. So an LCD initialization for LCD, and we need a function called delay, because we need some delay on each and every whenever you have whenever you switch over to the next command, like you need to have some delay. So we need a delay function. Okay, so the initialization function, like I'm going to use the inbuilt I'm going to use the header file from the STM microelectronics. So it will be stored as a structure. I'll show you once I do in the program. Okay, so RCC, you can access RCC AHB1 so the memory will be stored, the address will be already stored in the header file, so you can directly give the value for 06. Okay, so 06 is nothing but you give you enable the clock for both the GPIO B and GPIO C. And GPIO mode or register, you have to set 5400. This is to set the output 567. Okay, to set 567 as the output. And this is to make enable and read rate low to set GPIO B BSR register. Okay, and mode or register you configure as 5555. 8 is to set all the 8 bits, like from C0 to C7 as output mode. Okay, so these are the value which you have to set. An LCD command, to give the command to the LCD, first the GPIO B, you set both RS is 0 and RW is 0. Okay, and give the command, enable it, and you have to clear to enable. For enabling, you need to give a pulse. Okay, first you have to by default it will be low, so you have to enable this line for a high, and left for sometimes, for you give a delay for 1 milliseconds and then you low again and make it low again. Okay, so that is taken as an enable. Okay, a short pulse is taken as an enable. So you need to make it, by default it will be low. Okay, you have to make it high and give some delay, and then you just make it low again. Okay, so this is for command. And for data, you enable RS. For command, it is register select is 0 and read rate is 0. Okay, it's RW is 0. Okay. For data, it's RS equal to 1. Okay, and RW equal to 0. So you set this BSRR. Okay, and you just clear this. RW equal to 16, just clear. And data, you pass the data here. Whatever the data which comes, you pass to the output data register, and you just enable this line. Okay, so for enable, you have to enable it and give a delay for this for 30 milliseconds, and you clear this enable. Okay, and for initialization, like GPIO underscore init, so pass the command 38. Okay, and 0C, 06, 01 or clear screen, and to move the cursor. Okay, so 80 is to turn the display on. Okay, so here is a code. If you can refer to this. 80 is force cursor to the beginning. Okay, and 30 is for choosing. It's a 2-line 5x7 matrix, and 01 for clear display screen. And okay, so these are the codes. These are the codes. First you send the commands, and then you send the data. Okay, once you send the command, give some delay, and then you send the message. You send the message to the data. Okay, so this is in LCD underscore init. So this program is for delay. Okay, and this is the main program. Okay, let's go for the code. So before we go for the code, let me open the ST Microelectronics website. Okay, I just go for st.com. Here I have already logged in. Okay, so you have to log in. It's free. You just sign up for the. Just give me a moment. Let me sign up. Okay. Okay, I have logged in. I go for search. Okay, click search and search for Nucleo F411 board. you search for Nucleo F411 board. You will get the product. Okay. Okay, Nucleo F411 RE. Just choose this product. Okay. You have options to download the documentation part, like the data sheets. You can download the data sheets and user manual here. Okay. You have option for the CAD resources, like if you want to download the schematics, manufacturing files. Okay. The Gerber files, the schematic files, the bill of materials, you can download here. And tools and software. Come for tools and software. So you just MCU and MPU embedded software. Okay, you just download this package STM32Cube F4. Okay, so STM32Cube MCU package for STM32 F4 series. Okay, you just click this and you click download. Okay, so STM32Cube F4. Okay, get latest. Click accept. Okay, and just download this. Okay, once you download this, go for okay. I'm just going to create a folder. Okay, right click, go for create a folder called LCD. Okay, LCD. Okay, inside this folder, let me create folder called target. Okay, open this, copy this. Okay, let me open file, go for new, go for STM32 project, switch workspace. Let me switch the workspace, click other. Okay, and I paste this, click launch. Okay, okay, I just go for downloads, go for I just copy this and I'll okay, I'll just paste it here. I'll extract this folder. Okay, I'll extract this folder. So meantime, I just create a project, go for file, go for new, go for STM32 project. Click board selector. Click board selector. Just type Nucleo F411RE. Okay, choose this one. Click, choose this board. Click next. Okay, just give a project name. I just give a project name called LCD and choose the project type as empty. Click finish. So just click the source file and open the main.c. So let me increase the sorry. Okay. Okay. I'll just remove this code. Okay. And let me include the hash include. Since it's a user defined header file, you have to use double quotes. Okay, stm32f4xx.h. Okay, save this, right click and build the project. Okay, so we have error. Let me make it okay. Okay, so you could find out this error, like it is not, the file is not included. Let me go for the folder. Okay, and I have to open this. Just go for drivers. Okay, and just go for drivers, click drivers, and click CMSIS, click include. Okay, have to check for STM32. Okay, STM32, go device STM32F4X, click include. Here is the file. Just copy this, right click and copy. Okay, and just right click, go for properties. Okay, and choose this C++ build, click settings. You need to come for this GCC compiler. You need to click GCC compiler, go for the include paths, and you have to include the path of that folder. Okay, click OK. Click OK. Okay, apply and close. Let me check, right click, build the project. Okay, so you choose this, right click, go for open declaration. Okay, you have to configure the symbol. Okay, F411X, you just choose this, copy this symbol, okay, and right click, go for properties and choose preprocessor. Okay, and you have to add this, symbol. You have to add the symbol. Okay, click OK, apply and close. Click yes, right click and build the project. Okay, so this file is not there. Include core cm4.h is not there, so we need to include this core file also. So just go for source. It should be on the search for that file. Okay, sorry, just go for CMSIS. Okay, hash include, it is here. Like, just copy this, right click. Let me check this core underscore cm4.h. Okay, core underscore cm4.h is here. Okay, so I just copy this path, right click, I just copy, open this, right click, go for properties. Okay, you have to include the path, GCC compiler, go for the include path. Okay, and click this, click file system, give the path. Okay, select the folder, click OK, click apply and close, click yes. Okay, Now right click and build the project. Okay, so the file is linked now. Okay, so let me click main.c. Okay, the file is linked now. Let me control. Okay, let me reduce the. Okay, so the file is, this header file has been linked now. Okay, now you can you just define the macros. Hash define. Okay, sorry, define rs 0x20. Okay, copy this. How to can, this is for read write. Okay, and this is for en for enable. So enable is 80. Okay, and this is 40 and this is 20. So if you get the binary code is 00000010. Okay, and for 40 it is 0100 and 000. Okay, for 80 it is, okay, because it is connected to, the reason we have given is it is connected to PB5. Okay, PB5, PB6 and EN. Okay, so it's connected. PB5 is connected to RS. Okay, it is connected to RW, it's connected to EN, and PC not to PC7 is connected to D not to D7. Okay, D not to D7 in LCD. So let's define the prototype now. First, let us define the unsigned char, the message. Okay, message I'm going to give as Pantech. Okay, and okay, so first let us initialize the GPIOs. To initialize the GPIO, okay, so let us create a function. So void GPIO underscore init. Okay, so let's define this function now. Okay, so the first we need to set RCC. How to enable AH B1 ENR. Okay, AH B1. Second, how to set, you have to set the mode register, GPIO or GPIO mode register, GPIO B mode register as output. Okay, you have to configure this output. GPIO, this is B. The same way you need to set GPIO C mode register as output, and then you have to set you need to set EN as low. Okay, so you for that you have to use BSRR register, okay, bit set register of GPIOB. Okay, as low. Okay, so this is what, so to define this, so previously what we will do is, like, we'll be declaring a pointer. Okay, by using we'll go for Windows show view SFRs, and we will take the the memory address. Okay, memory address show view sorry, Windows show view toggle. Okay, so but now like you can go for the RCC register. Okay, RCC, like you can find out, like you just open declaration, you could find out all the registers here. Okay, on this file, click open declaration. Okay, sorry. Okay, so you can find out all the registers here. Like these are the if you want the RCC register, you can find out the control F. You search for RCC. You can find all the RCC registers here. Okay, all the RCC register is here. Okay, this is RCC type def. Okay, and for this is RTC. So GPIO, SPY, timer, USART is here, and watchdog. So timer is here. Okay, so all the memory address is declared here. Okay, what we're going to do is, like, I'll just go for RCC. Okay, to access that, you just type this and wait for this. You will get AHB1ENR. You choose this AHB1ENR. Okay, and then you set the R of 0x06. Okay, 0x06. Let us go for window, go for show view, project explorer, right click and build the project. Okay, we forgot to put this. Okay, right click and build the project. Okay, so let me call this function GPIO init on the main program. Okay, so you can check whether the bit is set or not. Okay, Windows show view. I'll just click the project explorer, right click, go for debug. I'll just set this LCD debugger. Okay, choose ST-Link, and serial wire viewer is also enabled. Click apply, click OK. Okay, click switch to debug perspective. Okay, so if you click the SFRs now, SFRs, you just go for the RCC register. Okay, RCC register, and click a AHP1ENR. Okay, so it is set now. You can see this. This is GPIO B and C. Okay, so you can find out on the data sheet, like this is you have to set GPIO B and GPIO C. It's set now. Okay, GPIO B is set and GPIO C is also set. Okay, now let's go for GP. Just type GPIO B, and to access that register, this is mode R. Okay, mode R. Click this and how to configure 0x54. Okay, 5400. This is to set 567 as and GPIOC. Okay, click the mode R register. Okay, zero x 00. Okay, 555. Okay, set. And for setting this GPIO, okay, this is BSRR. Okay, 0x00C. Okay, this is to set the appropriate. This is for set EN and RW as low. Okay, so let me run the program again. Okay, so it's run. Build failed. Okay, sorry. And let me save this program. Okay, right click, build the project again. Okay, it's okay. So we have configured the GPIO underscore init. The next is let's write the program for LCD command. Okay, LCD command and LCD data. Okay, LCD, just give LCD command. Okay, and this is for LCD data, sending for LCD command and LCD data. Okay, LCD data. Okay, so let's write the program for command first and then the data next. Okay, for LCD command, the first is, if it is command, you have to put register select, it should be 0, and RW is also 0. Okay, this is for command. If it is data, you have to use this mode as 1. Okay, and in order to set this RS equal to 0 and RW equal to 0, like you can use this BSRR register. Okay, just copy this BSRR register and equals, you can use RS. Okay, both are 0, so RS or RW, shift it 16 times to make it clear that. Okay, and to output data register, is store that is how to command. You just pass this unsigned care of command. Okay, unsigned care of command. So copy this. Okay, you pass this command here. Okay, and you need to enable, you need to give enable. Okay, for you need to make enable en is 1, en equal to 1. Okay, in order to do this, you need to go again, you need to use this BSRR. Okay, just give this en. Okay, give some delay. So we need to write delay function. Okay, delay milliseconds. Let me give us 2 milliseconds. Okay, I'll make it as delay milliseconds. I'll make it as 30. Okay, 30 milliseconds of delay, and I make this as again low. Okay, this is to clear. Okay. So we have to write the delay program. So void okay int delay. just copy this, write the delay program. Okay, so just initialize an I variable for delay greater than 0. Okay, just give delay for this has to be since we are using like 16 megahertz. Okay, so this value should be 3195 to give this millisecond delay. Okay, so delay is completed, so let's delay program is completed. Okay, sorry, ODR. Okay, equals okay. So let me check, right click and build the project. We got two errors. Okay, so right click and build the project. Okay, so data is finished. Let's write the command. Sorry, command is finished. Sorry, this is command actually. Okay, it should be command. It's not data. This command. Okay, so data we have to do. Okay, data is here. Data command is completed. So this is data actually. This is data. Okay, so for command it is rs equal to 0 and rw equal to 0. This is for data, it is rs equal to 1. Okay, so this is command, lcd command. Okay, this is data. This is data. Let me check, right click, build the project once. Let me check for any error. Okay, so let's write the program for the data. Okay, rs is 1, so I just copy this. Okay, since rs is 1, so you need to split this into two. You have to split this command. Okay, this is rs, and again you make it. Now you copy this. Okay, this is for rw equal to 0. Okay, and ODR, the output data, it's data here. It's not command, it's data. Okay, so data, you copy it data, and you have to do, you copy this for making enable. Okay, for enabling, you just copy this and paste it here. Okay, just give a delay. Okay, so command is okay and data is also okay. Now let us write the program for LCD init. Okay, so let's write the program for LCD init. void. Okay. So let us call this function here GPIO underscore init on LCD init. Okay. So LCD, just first is command. You just copy this command. Okay. Command we have to pass is 0x38. This is for settings. It is 16 plus 2. Okay, the mode is 16 plus 2. And just give a delay of 20. Okay. So after that, you pass the command as 0C. Okay. And cursor to the right. Then 06, 01. Okay. And for this is for turning on. Okay. So here you can pass the message while just check the message of I. So you have to declare this I here. Okay. So unsigned char of I equals 0. Okay. If I not equal to empty, okay, this is okay. Just give this LCD underscore data. You pass the message. Okay. Sorry, pass the message of I and just give I plus plus. Sorry, increment the value of I. Okay, just give the delay. Just let us increase the delay for 50. Okay. So call this function here. Okay, LCD init. Right click, build the project, message. Okay. Okay. So right click, build the project. Okay, right click, go for debug and STM32. Okay, and hit the run button. Okay, so let me switch on the camera. Like you could see this Pantech. Okay, let me change it to hello. Hello. Okay, and I recompile the program again. Click OK. Okay, you could see this output here. Okay, and hit the run button. So you can see hello now, and let me change to ESD ARM Cortex. Okay, ARM Cortex M4. Compile this. Click OK. Click switch. Okay, and hit the run button. So you can see the output here. Okay, you can see the output here, like ESD ARM Cortex M4. Can slightly adjust this. Okay. So with this I close this lecture, or let me explain once. Like give RS RWENS 204080. Okay, message is declared. Okay, declare this is function. This should be data here. Okay, this should be data here, but still it works. Okay, data command init delay. Okay, and this is for the LCD data, LCD command, and GPIO init. Okay, and this is for LCD init. So with this, sorry, I have not. Okay, let me show the screen again. Like you have to, I have modified this as data here. Okay, LCD data command init delay milliseconds. Okay, I have just given the delay here, and LCD data. This is the code for LCD data. Okay, and for LCD command and GPIO underscore init and LCD underscore init. So with this, I close this lecture, and let's go for the today mindset lesson. So today mindset lesson is about it's about energy and vibration. Okay, so the universe responds to your frequency. Okay, like for example, like if you're vibrating with a different frequency, like if you have a lot of fears, and if you have guilt, and if you have shame, you're going to attract the same thing of vibration. Okay, so instead of you have a love, joy, and compassion, and abundance, you are going to attract things that supports this frequency. Okay, so it's just like tuning the radio station. Okay, so you just tune the frequency and hear whatever you want to hear. Okay, the channel what you want to hear. The same thing is like you have to tune the frequency for success. Okay, if you're in fear and guilt, then you will attract the same thing. If you're in love, joy, and abundance, you will attract the same thing. Okay, so it's all about the frequency. So change your frequency and change your life. So this is the lesson which I'd like to share you today. And about the activity, write down your top 10 goals, write down your top 10 ideas, and 30 minutes to work out, and 50 minutes to meditate, and 10 minutes to visualize, and 10 minutes to focus on the day plan. Okay, and 2 hours of learning and take notes. Thank you so much for your time. Please do post the activity on the Facebook group. Thank you so much. See you on the next session tomorrow. Until then, bye bye. Take care.